Right, sir. Yes, sir.
Hello, are you able to hear me? Hello, are you able to hear me?
Yes, sir, we are able to hear.
Okay, session is going on. Huh? Okay, I will wait for some time. Okay, fine.
Good afternoon, sir. Can you hear me, sir? Venkateshwar, sir.
I'm able to hear. Okay,
Just
is
2 minutes,
other
sir.
session is going on?
Just
Then I
2
will
minutes.
wait.
Session was going to end now. It is
Okay,
going
fine. I
on,
will
sir.
wait. I will wait. I will wait.
Just 2 minutes. Okay, 5 minutes started, sir. Thank you, sir. Sir, good afternoon, sir. Venkateshwar, sir. Excuse me, sir, we made you wait.
Sir, Venkateswaran sir, good afternoon, sir.
Good afternoon, sir. Good afternoon.
Yes.
Faculty, participants
Yes,
are joining, sir. Just now it is ended.
No, no, no
Previous
problem.
session.
Yeah,
Okay,
Dr.
sir.
Mayank Tiwari just concluded that rotor nonlinear behavior of rotors. That session,
okay.
sir. Yes,
Okay.
IIT Patna. With
Yeah.
your reference only, we contacted him, sir, to be
No, he was
more
my
genuine.
external guide.
Yeah.
Sir, we will have session up to 1:15, sir. Immediately we will start valedictory.
Sir, can you kindly excuse me from the valedictory because I have to go outside? Okay.
Okay, sir.
Okay, fine, sir. No problem. No problem, sir. You please wind up at 11 by 1:15, sir.
Fine.
Thank you, sir.
Thanks.
We'll wait for 2-3 minutes, sir. People are joining.
Sure, sure.
Thank you, sir.
But otherwise, everything went well, right? No problem.
Yes, fine, sir. With your kind cooperation,
No, it's okay.
with your reference, everybody prompted
this has
nicely, sir.
ended, and we have to thank you very much, sir, because in all the references you have given, and through your reference only, we approached all the experts, and they readily agreed to demonstrate their expertise. That's really
Even
good.
yesterday, Veerbhadra Reddy sir has given lot of exposure, sir, regarding instrumentation.
Okay.
Hello, biker. Hello.
Yeah, I think now
Yeah.
we reached
It's almost like a lateral tour of a vibration testing laboratory, sir. Yesterday.
Okay, okay.
That's it.
Mhm.
So the Arun,
Shall we start, sir?
sir, please wait 1 or 2 minutes, sir.
Okay, sure.
Please, thank you. Only 13 are there, sir. Actually, every day about 40 minimum are attending, sir.
Okay, okay. Maybe there may people.
Okay, sir. Just
Okay,
we-
sir. Sir, Dr. Venkatesam Garu. So once again, welcome to this session, sir.
Sure, Professor.
Yeah.
Thanks for
Yes, sir.
yeah.
Yes. To all the participants, and there is no. I think there is no necessity for introducing Dr. Venkatesam sir, because he's such a renowned person over here in these areas. And sir will come up with a demonstration which he has been insisting since the inception of the idea of this particular program. So as we are running out of time, to request sir to take over the session, and please go ahead, sir. Thank
Sure.
you, sir.
Thank you very much, Professor.
Yeah.
Here, just I would like to convey one thing. When we are teaching the vibrations as a elective, because I'm talking more like as a teacher and as well as how to promote the vibration course, okay, in various colleges. That was the main idea for this particular session. Okay, so one is your personal one. How can we promote the vibrations as a subject at a college levels? That was my main motivation for the today's talk. So when we try to teach the vibrations, we always write the equations and solve those equations and try to interpret it. But when it comes to the lab, okay, majority of the time the dynamics lab is the least preferred lab from the management point of view to establish, because of the very expensive that people will felt. Okay, and relating the vibrations topic with experiments is like because of this notion, it's not becoming a popular to visualize it. So to take this as a challenge in a couple of years back, so I think around 6 years back, so we thought, why can't we use the open source platform to conduct the vibrations lab? Okay, to conduct the vibrations lab. But if you take it a typical simulators, vibration fundamental simulators, a couple of lakhs or couple of minimum lakh is the required. And even though lakh also, you may not get exposure to the sensors and the data acquisition system, those things. So in this spirit, why can't we develop it a trainer, and anybody can use it with a minimal effort was our main motivation. So today I would like to show how can you use the minimal sensors are available in RoboKits, or like with 100 rupees, 200 rupees sensors. So you can leverage those sensors to teach the vibration course. Okay, at least the fundamental course. That was my main idea. So here I will try to demonstrate how can we leverage those open platforms, hardware and software, for doing this. Okay. So with this one, what has happened? We want to develop. Are you able to see my screen? Is my voice is clear?
Yes, sir. Yes, sir.
Yes, sir.
Okay, fine. So my intention is we need to develop a vibration trainer, and that should be affordable, and it's affordable, and it should be accessible to everybody, and it should have a user friendliness. Okay, that was my main motivation for developing this vibration fundamental trainer. But if you look at it in a last session, I was talking about it. When you try to talk about vibrations, we need to do the free response systems and forced vibration response. In a free, damped and undamped. Similarly, forced, damped and undamped. And corresponding the in a forced systems, we couple of examples, base excitation problems, we try to talk about it. So shall we demonstrate the same in our labs, right? So this is the experiments, the 10 experiments we can plan to do it. One is the free vibrations without damping single degree freedom systems. We already discussed what the single degree freedom system is. Only 1 degree of freedom is there. Only one natural frequency you will get it. So when I'm doing the free vibrations without damp, what output I will get it? Natural frequency I'll try to get it. Then we have the underdamped systems with the free vibrations. So here you will try to get the not only natural frequencies, we'll get the damping values. Then the forced vibrations without damping single degree freedom systems. So here you try to get the feel of resonance. Then the underdamped, so you can see the logarithmic decrement, those things you will try to look at it, and the damping effects you try to understand. Okay, so single degree freedom systems, and we have 2 degrees of freedom systems. Okay, not only single degree, 2 degree, and repeat it same thing. Okay, free vibrations without damping, free vibrations with the underdamped, forced vibration without damping, forced vibration underdamped. And there is a base excitation problems and logarithmic. So there's a couple of experiments you can do it in your lab. So for doing this, what is the hardware we'll try to take it is. Everybody knows it. We have a Arduino board. It's hardly cost you the board what we use, at the time it was 200 rupees. Okay, that is like a 200 rupees you can get the board. Okay, if you as a mechanical we are not comfortable, but most of the kids knows how to code it in an Arduino board, or you can leverage with your electrical department colleagues or electronics department colleagues. So for them this is like a for us measuring the the typical pressure, we use the pressure gauge, right? For them this is like that. And there is a MES sensor, this is a MEMS sensor, and it has a natural frequency of 40 Hz. So I can measure comfortably up to 20 Hz. Comfortably I can measure the frequencies. This is a MEMS sensor, and it costs you around 200 to 300 rupees. It's easily available. So you need to do the proper soldering, and this should be placed in a to mount it. You need a mounting small base plate. Okay, you require two MES sensors, a Arduino board, and to provide the excitation of the signal. Okay, to provide a signal. Generally, I think maybe yesterday Mr. Veerabhadra Reddy showed it, various shakers when you're doing the vibration testing, right? That very high end one. We don't require that. Your typical speaker, that 1,000 to 2,000 rupees, your base speaker, you take it, and amplifier. This may be available in Hyderabad, in Koti. You go to any place, you'll get that. Okay, and then is a cantilever beam. Okay, and there is a cycle spoke. Whatever the cycle spoke is there, that is the one will be the stringer for our problem. So we are able to build a shaker excitation for providing the base excitation, and a spring mass system with a vertical arrangement. We'll try to do that. Okay, this is a normal hardware available. It's hardly cost me like a 4,000 rupees. Okay, hardly cost me like a 4,000 rupees. So then what we'll do, we'll try to establish the proper connections with the ground by sensor. Whatever the sensor input is coming should go to your board. Okay, and that board will be connected to your laptop, and there is a Arduino code need to be dumped it. So those code we developed it. Just you need to dump it that. Okay. So then what happened to make it more robust, like it looks nice DAC system. So whatever the board is there, it properly packed it, and the power connection is coming from your laptop, and as well as all the sensors. You can see these blue wires are connected to the sensor. It's a one sensor, and another one is another sensor. So two sensors are connected, and power is given from your laptop USB based, right? So any prerequisites. So what we are expecting is this basic vibration trainer, BV trainer. You need to install the Arduino software and upload the Arduino code. We'll try to provide it. Okay, or you can write it your own thing. It's not a really hard thing. This is like done by a summer interns from third year mechanical students from NIT. They came and they did it. Okay, so then COM port is that you make sure when you're connecting the right COM port, you are able to get the data. Okay, that you need to check it and install the exe file. Okay, that is built it on a MATLAB based. So it has two features. One is conducting the experiment. Second one is simulations. So you want to demonstrate it, the various things. You don't connect the experiment. Still in a lab, you play with the numbers. As a virtual experiments also conducted in your class. So you have simulator also is there. Okay, virtual simulator also is installed in this. Okay, that's it. You can go ahead. So the interface to the software. This is the software was there. Okay. After installing exe, the left side is okay. I think somebody is
Yes, sir. Yes, sir. Some disturbance is going on. Okay.
Sir, you please unmute yourself, sir. Sir.
Sir. Sir, please unmute yourself, sir. Venkatesam, sir. We have mute.
Yeah. Now it's fine.
Yes, sir.
Okay. So now what I'm saying is left side you see the screen. This is the code exe file will come to you, and just you install that and hardware you buy it. So here what will happen is you can try to do what is the COM port number, as I said, like you can get it in Arduino code, and then number of samples and as well as the sampling frequency for doing the FFT, right? And what is the sensitivity of your sensor. So these inputs you try to provide it. The sensitivity is nothing but whatever the mechanical quantity and will be converted into the output in terms of the voltage. So it is like a, generally we'll write it millivolts per G or millivolts per meter per second square or millivolts per Newton. Okay, millivolts per Pascal. That is the sensitivity output by input. Generally in a sensor, output will be in electrical parameters. So that you will get it. So what are the experiments you have it? And this is the input data for your theoretical results. The right side is your simulations and output will be there. Okay, so if I don't want to do experiment, don't worry, you enter your simulations, various the 10 experiments I was talking about, base excitation problem or free and damp, those data you enter and create a simulation, so you'll get the corresponding output on the either side. Okay, so but what I'm saying is this is possible, you can come up with your own interface also, it's not really dependent on our exe file. Okay, you write it your own code, but you can conduct these various experiments. Just like how to do that is a user manual will come to you and you need to enter the corresponding user one. And so what type of output results you will get it. For example, I am doing the free vibration single degree freedom without damping. What is the output I will get it? In a simulations I will get a natural frequency. In an experiment you will get a natural frequencies. In correspondingly a simulation also you will get the natural frequencies. When you do a single degree with a damping, you will get the natural frequency and as well as the damping values. So you can see the damping values, the damped frequencies, and as well as the critical damping values you will try to get it. And so like this you will get it. So I will show you, for example, you see this is the top one is the time domain data and the bottom is the frequency domain data. So you see maximum 40 Hz only we are able to do it because we have selected the spring and mass such a way that the fundamental natural frequency is less than 10 Hz. Okay, so then your sensor is capable to pick up the signals. Okay, you don't really require a high-end signal. Generally the accelerometers can come up to 30,000 rupees. Okay, we don't want that type of very high-end sensors. We require a simple MEMS based RoboKit one with a lower frequencies. We are able to get the results nicely there. Okay, so simulations can be done in that. Then what happened, this is single degree with damping cases also can be done. So what I'll do is like this will be there. Just I will try to play a couple of videos, then you will appreciate it what I'm talking about it. So are you able to see my screen?
Yes, sir.
Yes, sir.
So I'm playing a video, you are able to see, right? Video.
No,
Not yet,
video,
sir.
video not.
Screen is
Okay. Yeah. Now
yes, sir.
you are able to see the screen, right?
Yes, sir. Yes.
Video.
No, yes, sir.
Okay. I'm playing sound. Are you getting the sound?
Only video.
Only video.
Okay.
Yes.
Okay. Are you able to hear the sound? No, right?
Sound is not audible, sir.
Fine. What I will do is now I will give the commentary. Okay. I will play again. Okay. I will give the commentary. So now. So, okay. This is the forced vibration, no damping. So no damper is not involved. It's a single degree freedom system. Okay. Okay. So you can see here, this is a cantilever beam. Fine. Okay.
Yes, sir.
This is a cantilever beam and connected with a spring mass system. This is a spring connected with a mass. This mass is like a disc, right? And number of coils you design it such a way that the natural frequency of this complete system will be less than 10 Hz. You design it your springs like that. Then there is a sensor is connected. Okay. And the two sensors we are trying to use it because that is just for the getting the averaging. Otherwise, one sensor also fine. So you take the sensors connected to Arduino. You can see here that is the Arduino was connected, right? You can see the Arduino here. Then this is the speaker, normal speaker. You get it from local market. Okay, this is the speaker, and we remove the top screen just because the speaker works also is electromagnetic excitation. So when you give a current, means the signal you give that is electric, that magnetic fluctuations will happen. So then this is the cup. Somebody can guess what is this cup? Somebody can guess what is this cup? The red one. This is like you have a cone, like ice cream cup, right? Ice cream will be pop, like, it will come in a small plastic box now, some particular flavors, right? This is the top cup. So we are connected here with a glue, right? And whatever vibrations are there comes to this red cup, the plastic cup, and we applied a double-sided tape here, right? And this is the cycle spoke, okay? The cycle spoke, and we have drilled it and connected here. So now what happened? Whatever vibrations are happening on the speaker goes to the stringer. This is a stringer. It's like nothing but this your exact means like your vibration shaker. The speaker is converted as a vibration shaker. So then this connected to the base, right? We are trying to provide an excitation, base excitation to the structure at the thing, and the response is picked by this MEMS accelerometer, and the data current system is your Arduino board, and this completely connected to your laptop. Okay, and the laptop is installed with our software. Okay, whatever the exe we have created, and then you can conduct the experiment. And the other end of the table, okay, just I will try to move. See. Okay, now what happened? This is the typical amplifier used for the speaker playing one. It's like hardly 1,000 rupees. What we did is we already recorded the frequency of whatever frequency we want. That is in YouTube or everywhere you available. If I want to assign 10 Hz signal or tonal frequencies, whatever is there, audio file, 10 Hz tone, 20 Hz tone, or 30 Hz tone is a wave format in audio file, and that we have put it in through USB. Okay. So we are playing, you are playing songs, right? In the same way, I am playing a wave file that is a tonal in nature. So that's a wave file is amplified, given to your speaker. So now speaker will try to play a song of 30 Hz tone signal or 10 Hz tone signal. In this case, we are doing a 10 Hz tone signal, and correspondingly the diaphragm is vibrating at a 10 Hz ideally, and that will be transferred to your cantilever beam. Clear? That is the one we are trying to give a forced excitation. So we are trying to do the experiment. Already we have given the what COM port is given and sensitivity of the MEMS sensor we have given. Just we'll run that. See the shaker is vibrating. You can see the shaker is vibrating. The base is exciting. Corresponding vibration response is coming on a mass, and it will be shown in this. And this is the FFT. This is the time domain signal. Means you are trying to monitor with respect to the time. And bottom is the FFT, right? Means your frequency versus amplitude. Okay, we are getting the output of 9.48. This is given excitation. It's not a natural frequency one, it's a forced vibration. Whatever the frequency you are given, that response is coming. See, it's a pure tone you have given. So the vibration response is also pure vibration displacement was given or acceleration was given. Is it clear? Conduct the same experiment.
Yes, sir.
Yes, 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 sir.
Okay, damping one, we'll try to do that. Just I will close this. I will open the damping. Okay, now I will try to show the 2-degree freedom system with the damping. Okay. Are you able to see the screen? Now we'll try to do for this 2-degree freedom system. Okay, just I will play video first, later I will give the commentary. So, but the people who wants to get an idea, cantilever beam is provided by the C clamp. You can see the beam and it is connected with the here for C clamp. Okay, sorry. Actually, this is the force, not a 2-degree freedom system, single-degree freedom system. The title is wrong. This is a single-degree freedom system with a damping. Previously, what we did is we did a force vibration without damping. Now we want to create a damper. So what is the damper? We want to create a viscous damper. So for getting viscous damper, what we did is we took some can. Okay, within the can, what we did is a floating ball is placed. The oil is filled within the can. Right, a floating ball is there, and the floating ball is connected to the mass. Okay, so now what happens? The mass motion is controlled because when you try to move inside the fluid, because of the viscosity, what will happen? You are dissipating that energy, right? That is the viscous dash part. So whatever we try to do mathematically, the dissipating force is proportional to the velocity that is created by keeping a ball floating in a oil and one end of the ball connected to the vibrating structure. So this is the damping we have created. So the same force is not a 2 degrees, is a mistake in the title. It is a single-degree freedom system with a damping. Previously without damping, now with damping. So see, so this is the one, the mass, right? Okay, now this is the ball, and other end of the rod is connected to this complete was damper and connected to the mass. So spring, mass, damper system, right? Whatever you teach in your class under forced excitation given by the exciter from the speaker. So this is the system we have. So same as the previous system, just is played to the amplifier. You can see it's switched on, and you can see the shaker is vibrating and vibrating at a 10 hertz. We are trying to provide at a 10 hertz and damping system. So I think the so is press the perform experiment button and you can see. So it's acquiring the data and try to display that. Yeah, you can see it's acquired the data and display. Because in a first amplitude you observe it in a comparatively undamped system. Okay, comparatively undamped system, damped system has a lesser amplitude of vibrations. That is the one we'll try to show here. Okay, the next one is we'll try to show another one, that is a 2-degree freedom system. Okay. Okay, now we will try to demonstrate the force. You can see the click here, forced undamped 2-degree freedom system. So 2-degree freedom system is spring 1 mass, spring 2 mass. So look at that is the way we call it as a 2-degree of freedom systems. So we'll try to look at it how we can do that. So two frequencies should appear because 2 degrees of freedom. This is the beat, one spring, mass, spring, and second mass. Sensor 1, sensor 2. Connected to the Arduino board. So we are trying to excite at the same center edge. Okay, switch on. So we are given the base excitation there. So now okay, the frequency response of the sensor 1 and sensor 2, you can see that. Okay, so then one more experiment, what we learn, the free vibrations of the 2-degree freedom system. So free vibrations of the, okay, so here when you try to do the 2-degree freedom system for free, so what will happen, there is no base excitation, just you need to disturb from the initial condition and observe the motion. So for that okay, now I'm trying to display the undamped 2-degree freedom system free vibrations. So select the 2-degree here, free undamped 2-degree select. Then you put the mass, see, so hold the mass and disturb from equilibrium position. Be careful with the thing. What will happen? It should not become non-linear because of the pull, and you try to leave it. It should not become non-linear. Carefully the experiment, and also the horizontal motion should be avoided as much as possible when you're doing initial distance. That will be taken. So 3 hertz is a one frequency and 3.9. So there are two frequencies where we are able omega 1, omega 2, we are able to get it. Okay. So what I'm trying to say that with these systems, we can try to simulate it to complement the whatever theory you have learned it, or even you can conduct the various experiments and do the theoretical calculations and compare them. So this is exactly will done by the vibration fundamental trainers, but they use the little bit high-end sensors and as well as the exciters. Means like what I mean is a shaker, exciters, those things. But that might be an expensive toolkit. So here my intention is you can teach vibrations and you can feel the vibrations from by using these simple tools. So I encourage the faculties, if they are interested, they can build this type of rigs and integrate it as part of the lab course in a dynamics course. Okay. So I would like to pause it a minute and take the any questions or inputs. And if somebody is interested, we are ready to share the code, the exe files, and you and even user manual. Okay. So that user manual will also whatever I explained it now, you can feel it. Okay.
Yes,
Yeah.
yes,
This
from
is
the
the
audience side. Hello. Yeah, from the participants. Do you have any clarifications required or queries?
Sir, Venkateshan sir, can we give, for example, the input as some violin, musical input, sir?
sorry, sir. I'm not able to hear you. Your I think there is a fading in your voice.
No, no. What I'm asking is, you have given some music, that vibration input through speaker, sir.
Right.
When you said that you can download it from YouTube, so in that sense, can we have any musical instrument output, for example, violin, and
You
give
can
it,
give.
sir?
Yeah, you can give, sir. Actually, it is nothing but your speaker. Okay, what you try to play the audio files, right? That is the one we are using same audio file. What we did is instead of sound should come out, whatever the vibrating membrane is there. For example, generally there is a speaker and we'll try to vibrate it, but the paper membrane we removed it and only that shaker is vibrating. Right? There we put the cup. That cup also I told ice cream top cover. Okay, ice cream cup top cover. So then what happened? Now we are converting into vibrations only. We are not converting to sound. In a last class I told you, right? Vibrations convert into the sound, right? Okay, vibrations convert into the sound. So that part will be taken care in that way.
Okay, sir. Out of plane vibration. That will
Yeah,
not be.
it's like vertical excitation you are trying to provide it. The membrane is vibrating like this, right? The speaker diaphragm. So there you put a spoke and that will be vibrating in the vertical direction.
Thank you, sir.
Yes, any other questions from the audience?
How many people are using the vibration fundamental trainer as part of their course or like as part of their curriculum?
We are using, sir.
Okay, good. So now what I'm like, if you want, like I'm ready to share that exe file and you can use it because this is not a very expensive one. Okay.
Yes.
Typical small project. Okay, and maybe you can, yeah, fine. If you have any questions, then say, otherwise you can.
Yeah, any questions from the audience? And sir, regarding that software, what you have demonstrated on the laptop, is it available online or do we have to take it from some other source?
No. Actually, that is customized for this application, right? We wrote it, frankly speaking.
Okay.
This is our customized one. That is
Yes,
the reason IIT Hyderabad logo is there.
Okay, yeah, that's it.
Okay, we wrote the MATLAB code and as well as Arduino code by a couple of interns who comes from summer intern, right? They wrote it, that code.
Yes, sir.
I'm ready to give that exe. I don't have any problem. Only thing is you have to buy the Arduino code and these cables, those things you have to buy.
Sir. And sir, our HOD will be interacting with you, sir. Dr. T. Ram Mohan.
Yes, sir.
Sir, good afternoon, sir.
Good afternoon, Professor.
How was the total course, sir? Actually, you are the guide for us with your a lot of effort as well as your guiding continuously for this FDP. How you felt that, sir? About how the participants, is it they are
I think my best is we may need to take the feedback from the participants because end of the day, we as a teacher, we always talk from one side, right?
Yes, sir.
Listeners knows what we are trying to deliver.
Today we are in the validatory session, we are taking their valuable feedback also. But I thank you very much for your continuous support, sir.
Yeah, thank you very much. And pursuing this and in these difficult times, also we are able to demonstrate and as well as we are come together for the promoting the vibrations topics on behalf of. I can say that as part of the interacting with you, I would like to thank all the team members who worked for to make this successful. Okay.
Even I got from the faculty, they're telling that it's a very limited time. It required some more time to fetch about the different data acquisition or vibrations. Can we extend this for another FDP, which will be touching about the advanced topics or the continuation of the what all the faculty has delivered in this FDP, sir? Is it possible? Can we do it?
Sir, actually it's possible, but what I suggest is generally the people will get more because otherwise in online it's just a give a keywords.
Yes, sir. Yes, sir. Yes, sir.
So whatever the sessions happen till now, we'll give a keyword and somebody wants to pursue PhD. So who is the right person to be contacted? Okay, that is the information will be given in this all 5 days. if somebody asks me nutshell, what I learned is I learned the keywords for searching in Google, what word I need to search. Okay, I can't expect more than that, frankly speaking.
Okay. But if it is a physical mode, I think they can get more and more than they can.
Exactly. For example, today the demonstration, the people may not appreciate it, but if you try
Yes,
to
sir.
press the buttons and feel that the people will be really appreciated. Otherwise, okay, they did it and they developed it. Okay, it may be useful.
Maybe
That way.
I think even after I gone through all the sessions, even I felt that definitely this is a stepping stone for scholars or those who are pursuing PhD in this area. Definitely some inputs they might have gone through it by doing this FDP, I think.
Right. And another one is at least give a confidence that vibration is not a very tough subject, because
Yeah,
unfortunately
okay.
there is a notion that vibration
Yeah,
and acoustics means is a very tough subjects.
okay, okay, okay.
So
Right. Thank you, sir. Thank you very much for your continuous
sure.
support for even with your motivation, with your back end, we done this FDP, sir.
No, it's okay. I'm just a torch bearer.
Thank you for the
Thanks. Bye.
support, sir.
Okay,
Right,
bye.
sir.
All the best.
Bye, sir.
Okay. Okay, sir. Thank you very much. Sorry, I couldn't join for valedictory session, and I have to go for another outside.
Principal garu unnara? Join
Thank you.
ayyara?
Okay, sir. Thank you, sir.
Thank you very much, sir. Venkateshwar
All
sir.
the best.
We'll
Say
get
thank
back.
you. Okay, bye.
Yes, sir. We will get back to you, sir. Shortly.
Sure, sure.
Thank you very much. Kuchhodi, yes. Principal sir.
Yes. Yes, all respected participants, just please wait for some time. Our principal sir will be joining, maybe just a couple of minutes, just 2 minutes. He'll be joining shortly, and we will be commencing this valedictory function. And meanwhile, if you wish to share anything, just please, you are open. And meanwhile, please fill the feedback form that is attached to you. And
Please take the
and we have given a token test, a very small test to you. On this, content of vibrations. Just please go through that and try to answer that test. Okay.
ఇప్పుడు పెట్టుకురా పెట్టేస్తారా
లేదు అయిపోయింది క్లోజ్ చేసి వేలాది
ఇప్పుడు ఎవరైనా వచ్చిన తర్వాత అప్పుడు చెప్పండి. అది ఎవరి స్థాయిలో చాలా
మన స్టూడెంట్ సార్
అవునా
ప్రొడక్షన్
అవునండి.
Yes, a very good afternoon to you all. And now we are on to the concluding part of this faculty development program. Now our Dr. J. Anjaneyulu will take over the session.
Good afternoon, esteemed participants, and thank you for your support by attending all the sessions all through these 5 days. And it is the day we want to conclude. So just I want to give the brief about our program. So actually we have received 152 registrations, and also we can say that 50%, about 75 are net, we can say gross participants are participated here. And on any day average, we see that 40 participants are presenting and attending the sessions. And I hope this FDP program will be helpful for your future endeavors. And this is the time to thank our beloved resource persons, particularly main drive person for this FDP program, Dr. B. Venkatesham sir, who is constantly encouraging with our FDP program from the day one of the program proposal we made. And also end of the day also, actually it was not there in the program, end of the day he has agreed to give the demonstration. Because of these corona and physical constraints, we could not make it properly, otherwise we would have shown by live session also. Actually we showed the recorded session. And I thank Abhijit Sarkar sir, IIT Chennai, for his valuable lecture, particularly by using this Python program. He has given very nice lecture. And next, Dr. Anand Pare, IIT Indore, sir also has given nice lecture. And also Dr. Veerbhadra Reddy sir, yesterday we have got very good practical exposure, particularly what is happening outside in the industry, we could understand. And I think actually we want to request him to have the visit so that we can get more exposure over the vibration testing. And finally, today's lecture, Mayank Triwari sir, he has got very dynamic, that is particularly in dynamic stability. He has given overall nice lecture, and I thank one and all and for your valuable time. And I hope you should have taken some inputs by this FDP. And I will and thank you one and all. I want to, and also I request you people. May I ask one of you or some of you respond? I want to get the feedback, particularly oral feedback. Anyway, we have shared the feedback form. You may fill it, and I want the feedback. One of you please respond. May I request one of the participants or some of the participants respond?
Sir, good afternoon. Good afternoon.
Good afternoon, sir. May I know, please say your good name, sir?
Yeah, I am Dr. N.V. Srinivasulu, Professor of Mechanical Engineering from CBIT, sir.
Fine, sir. Please.
Sir, I am very much delighted to give a feedback about your FDP on vibration analysis and condition monitoring. It is a very important session for all the mechanical engineers and also teachers and students who are in the mechanical engineering. Without vibration, you cannot analyze any machinery that is to be laid down. So vibration is very, very important parameter that you are supposed to know for studying any machine. Even vibration is very much essential in the day-to-day life of an individual also, because you have positive vibration and negative vibration. So in a limited period, Vasavi College of Engineering has organized FDP on VACM very effectively, organized successfully also, and getting the resource persons from the eminent institutions like IIT Hyderabad, IIT Indore, RCI, etc. So I must thank Dr. B. Venkatesham Garu for his information regarding this vibration sessions. It's very extraordinary. And also the information shared by Tiwari sir, Anand sir, Abhijit and Veerbhadra Reddy sir, it was very good and it is very informative for all the people who are in the area of mechanical engineering. I once again thank the management and also the faculty of mechanical engineering department who have organized these sessions very effectively, and I hope there is a value addition for all the participants who have attended all the sessions in this particular FDP. I thank the organizers, especially Anjaneyulu Garu and then Rajendra Prasad, for taking effort to.
Okay, thank you, sir. Thank you very much for your positive response.
Give my valuable feedback. Thank you, sir.
Thank you very much, sir. May I ask any others to respond?
Yes, any other participant? Just please. If not, may I request our head of department to address the gathering?
Good afternoon, my dear participants. We have conducted this 1 week FDP program on vibrations and condition monitoring. I think it is very fruitful. I got the information from the participants as well as the faculty members of the continuous. I have touched with all the faculty members who have delivered the lectures on this FDP. They also said that the participants are very much enthusiastic about asking different questions on this VACM and vibrations. The main objective is to make them easy these vibrations to the participants. Generally, the vibrations, the faculty or even the PG students or the PhD scholars, they felt that this vibrations is very tough subject. But the main objective of this FDP is to make them it's easier, these vibrations. At the end of the FDP, they felt that yes, these vibrations are very easier, sir. With that motto, we organized this FDP program. And we are unfortunate that some of the topics what we planned was to make them easier, as well as the experimental setups what we wanted to show in a live demonstration, that we are unable to do it due to this online constraint. But anyway, today's session Venkatesham sir has demonstrated through a video mode. But if it is that's what even many participants, they advise it to go ahead with the offline mode. Yes, definitely we will conduct this continuation of this FDP with offline mode, and as well as in that the hands-on experience, or the instead of keeping a demonstration through online, we wish to do, we have the experimental setups are there in the department. We wish to do in offline mode, and the participants get that feel, that vibrations, as well as they can conduct some experiments in future course. With that intention, we wish to conduct this, or we wish to extend this FDP through an offline mode. In very soon we will conduct this, and definitely the participants will feel that the advantage of the different data acquisition systems available in the department. Through that, they can conduct the experiments. Even for the PhD scholars also, it is very useful for the future course. And also all the eminent faculties we called for this FDP, like starting day from Abhijit Sarkar from IIT Madras, who has delivered the hands-on sessions on the applications of Python programming. Then Anand Perry from IIT Indore on the concepts of condition monitoring, which focused mainly on the practical and theoretical aspects of the condition monitoring. He is delivered very nicely. All are delivered very nicely, which is very useful and fruitful to the participants, no doubt it is. And also, especially the Venkatesham sir, who is a continuously we are supporting for this FDP from the inception or from the planning stage onwards. So we thank the Venkatesham sir who has given, and also acoustics concepts also he has touched during his delivery of the practical exposure session as well as the theoretical session. Then especially I will thank the Veerabhadra Reddy sir, scientist chief of Research Center Imarat, that is the DRDO. Experimental philosophy of vibration testing has touched about that. The Mayank Tiwari for the today's IIT partner lecture is a non-linear dynamics of the rotors. He is touched about the topics. Is an excellent topic today. We have undergone this course. No doubt, with all these lectures, I hope we meet the objectives of our FDP. If any small problems or any technical issues are there, please excuse for that. And with all our encouragements, we will plan for our second FDP on the same topic. But if it topic may be the same, but definitely we will cover about the advanced topics of the vibrations and data acquisition. With this brief note, I thank one and all those who are patiently listened about all the lectures. I hope it will be useful for their future endeavor, especially those who are pursuing the research, as well as those who wish to apply for projects in different organizations like Department of Science and Technology, AICT proposals, etc. Definitely this will be a small feather. It will be added to the existing knowledge of the participants. I thank one and all. With all your encouragements, definitely we will conduct the other FDP session on this vibrations and condition monitoring. Not only that, we have received many number of registrations. Out of that registrations, we screened it, and also we are not giving the certifications to all the participants. We already shared the link for the test. Once those who got the minimum requirement of the test marks, then only we will distribute the certificates. Please cooperate for this condition. I hope then only the seriousness will come into the picture. Otherwise, just they will switch on and they will leave it to, and they will do their work. That we don't want to encourage. For that reason, we have conducted this test, and based on your score on the test, we will award the certificate. Thank you one and all for even for your management who are sponsored for attending this course also. Right, initially we thought to keep some registration fees, but actually we dropped it, and through this test we wanted to award the certificate to the original the participants, those who attained the basic minimum knowledge of this FDP. Thank you one and all. Now I will hand over to Professor Rajendra Prasad for the vote of thanks.
Yes, thank you, sir. Now it is time to thank everyone. First of all, the Department of Mechanical Engineering would like to thank all the participants for attending the sessions regularly and making this program a success. We thank the experts for delivering the apt content to the participants in the stipulated time given. We would also like to express our sincere gratitude to the management, Vasavi College of Engineering, Principal VCE, and especially our Head of Department of Mechanical Engineering for his continuous support throughout the program. And our special thanks to Dr. Venkatesham, who has been constant source of inspiration for us. We owe a lot to all our colleagues, both teaching and non-teaching, for their support in the smooth conduct of the program by assisting us at times. So thank you one and all, and especially our special thanks to our Srinivasu sir from CBIT. Sir, you have been there. You've been encouraging us for quite some time. Thank you, sir. Thank you very much. Thank you one and all. And we request you to all of you to submit your feedback as well as your test. And we'll take every care that your certificates will be issued to you shortly. So thank you one and all.
Okay, thank you one and all. Thanks.